Hello everyone. Can you hear my voice? Is volume okay? Great. So, yeah, my name is Pavel Smirnov, and I work at Linda, Studio Linda in Japan, of all places. So, and today I'd like to talk about pipelines and PDGs. So, the title says for small teams, and to show that, let me get back, that we are small, we're really small. So there are 15 people, and when I started at Linda 7 years ago, it was a pure Maya company, and slowly but surely we grew Houdini team up to, almost 8 people now. And, this big, what we do commercials. They are mainly like domestic commercials for Japanese market. And Houdini team also does some, big for our size, effects project for bigger domestic clients. And, so having not many people at your disposal, how do you manage to do work and how can you be efficient with that? So let's examine a simple pipeline task we might have. It's the simplest. We get some animation data from our client. It's usually Maya, right? I'm sure you heard of it. So, and it's on Windows. We use Linux, and we need to extract the animation data, the asset data. It may be some textures attached to that, to something Houdini can read. Those would be alembics, chunk files, ASS, RS in case of Redshift, and so on. So after that, we read it into Houdini, make our effect, right? And get it back into Maya. So if you have 1 or 2 shots, nothing to worry about, you just do it by hand. But there are some things to consider if you have more than 2 shots. So recently we finished a show with more than 100 shots, which quite big. Unfortunately, I cannot show you any images at this moment. So things to consider. Different platforms. Big domestic companies in Japan usually use Windows mainly. With some exceptions, but that's the point. External file dependencies. So each company has their own file structure, their own server locations, and those are different to our local stuff. Some third-party plugin dependencies. So they might have some in-house plugins which we need to accommodate for, and some plugins might need some special treatment, right, in order to get exported, because, so to name a few, you need to go to first frame, then you need to go to a second frame, and then after that it performs correctly or whatever. So, through the years I had a lot of things like that. So also multiple things needed to be exported from a single file. So, for instance, one shot could have a few characters, a few props, maybe an environment, fur, and whatnot, and those needed to be exported into different files and different file formats, right? And if something missing, something might be missing, we need to some way to notify that, right? And so how we went about that is we developed a Maya ROP. It's a Soho output driver, if I'm getting technical. So Soho is scripted output of Houdini object. I believe this is an API which Houdini speaks to renderers, right, in the output context. So I have a little video of that. Will it play? So, it's this one. Okay. So what it does, we provide it with a Maya command. Select a Maya version. then yeah, refresh to get oh, excuse me. It's kind of let's get it back. Yeah, get my command. Refresh. So this here it happens really quickly, but it takes some time actually. So what it does, it opens the scene and reads the list of the hierarchy transforms and shapes from the actual Maya file. So then we can yeah, pretty much set up Alembic exports for each assembly, for each root object or reference object. It will create a separate file of Alembic. Right. Yeah, it goes like this, or you can select the outliner. It has all the data now in Houdini, so you can select whatever you want to export. And it also can export render proxies, in this case ASS for Arnold. And I just want to quickly add motion blur to the characters, right? Motion blur, pretty nice. And copy the paths, the hierarchical paths of objects from Alembic. And it sets up the output files. We don't need camera, obviously, to Arnold, so yeah. Oh, sorry. Yeah. Next thing would be to export cameras. We use chan files for cameras. Yeah, and it's just export all cameras and it searches for the camera and export a chan file. Materials, no materials for this one, and it also can execute a custom Python script. So I won't write any script here, but here you can do some like special treatment stuff. And for instance, we use ftrack as our project tracking software, and yeah, basically you can do some update. For instance, this shot has this and this characters, this and this assets, and we can create links in ftrack based on that. Right, then you go and press render to disk, and it exports pretty nicely. Right, so having created that, if you have a large, big project, what you're going to do is to set up this node for each shot, right? And it ends up with a file like this. So what this is, it's an actual show, and it has 108 shots, I believe, here. So on the left-hand side, those lively colored nodes are assets. And on the right, the scenes, those are actual shots. So the good thing, well, it looks kind of ridiculous, right? So there's a lot of nodes there, but they're all like Maya-op kind of nodes. But the good thing about this, it could be sent to a farm. And yeah, kind of like this. So yeah, it works. Saves a lot of time and exhaustive effort, because if you're doing 100 shots by hand, repathing references from Maya file, that's kind of fun. It's sort of easy to scale. And well, one setup, it's one click. Let's get into the cons. Well, it lacks flexibility. A lot of it, actually. So, for instance, the Maya-op has everything in Python hard-coded, and you might want to change the order you export stuff. So, first you export Alembic, then you export ASS. But what if you need to export some guides for XGen or whatever, what have you, right? You need to update the actual node and that's kind of slow and may break other things. So yeah, it's not flexible enough. Dependencies are not very smart, so those are like your regular ROP dependencies. Requires a lot of Python. So Soho, who have tried to write it, it's kind of obscure for an artist. And I'm not a developer, I'm an artist of sorts. So yeah, Soho kind of dark and opaque to if you're new to this sort of thing, and it's really time consuming to write. So yeah. So how does PDG fit into this? Well, PDG first, when it came out in April, I believe, or earlier this year, I made a talk for Houdini launch event in Tokyo. And yeah, we had this pipeline with ROPs. So how fast could we transition to PDG? How fast we can achieve the same results with PDG was really exciting to see. So yeah, how I want to step back now for a little bit and see how we can deal with Maya. And the easiest thing to deal with Maya would be a Python script top, right? So nothing fancy. You can, it defaults to evaluate in process, so the actual PDG, the actual Houdini session evaluates that. But if you uncheck the evaluate in process, make a Python bean custom, and provide a path to your MayaPy file, binary, then it will execute the actual MayaPy, the Maya shell, right? But the only thing you need to keep in mind that MayaPy started needs to be initialized, and those two lines in the red frame input Maya standalone and Maya standalone initialize. This gets Maya initialized. So yeah, it sort of works. If I can get to Houdini now. Oh, great. Sorry, let's start another Houdini. Yeah. Sorry for this one. User interface. Okay, let me get back to here. Yeah, so another thing, well, it just works. So Python script top, you run it over a file, and well, it will create. So if you run it like this with no inputs, it will create one work item and start just one Maya. But if you provide, with a file pattern, you provide some actual files, you can run it as well. Right. So let's get into another slide. This will be a command chain. So this is a more advanced way to deal with third-party applications. It's more procedural, right? So at the moment, there are three types of command chains out of the box. So there is a Houdini server, there is a Maya server, and there is generic server. Well, Houdini server uses Python, right? Python shell of Houdini. And there is a great example of that in, supplied with Houdini in PDG / examples. Right, and generic one is just, I guess it's for development of your custom interactions with some other software. And there is Maya thing that allows you to work with Maya. So let's see how it does. Maya command chain. So here there's a pretty simple network. Look for shots, look for files, then fire up a Maya instance, Maya server, and send commands, right? There are only two types of nodes, basically. So there is this feedback loop of Maya command chain and command sense that would send commands to the server. Let's see how it does. So look for files, fire up Maya, then open a file. It actually, yeah, so you need an open a file in order to, excuse me. So it starts Maya, then it sends commands, but it doesn't open a file by itself, so you need to provide a script for that. You need to open a file. Then all these nodes are basically executed inside of Maya, and then, well, Maya terminates and you get the results, right? A few settings. So this one, it starts Maya PY, and you need to provide a path to that. And the way you do that is either you create an environment variable PDG Maya PY with the path to your Maya PY place wherever you have installed Maya. The other way would be to use environment edit on your actual work items. So in this way, you can actually modify which Maya you start, which installation of Maya you use, based on what file you are processing, right? And well, the simplest probably would be just the Maya server begin node. So this blue guy on the top, it has a Maya Python executable, and it defaults to /pdg Maya PY, but you can make an absolute file path there, right? So another thing I would like to cover is session count from upstream items. So what it does, if it's off and it's the default one, it sort of runs it in parallel. So you have, for instance, here we have 4 upstream work items. Those would be some files, right? So it would start a separate Maya for each work item, and those could be done in parallel. Whereas if you turn it on, session count from upstream item, it would be done in the same Maya instance serially, right? So it's similar how one would work with the Maya. They would start it and open, do stuff, save, open another file and whatnot. Right, so server items. If we cook a PDG network for just one item, there are one item throughout the network, but on the Maya server begin, there are actually 3 items. And it's kind of, why is that? So what's happening there is that we have a begin server item that starts, that actually fires up Maya. Then we have a session item that has all the, all the command sense, all the work done is done in the session item, and then end server is terminating Maya. So if we have those session count from upstream item off, we will have those like start Maya, start Maya, start Maya, run the scripts, and then Maya terminates for each upstream work item, right? And if we have this on, we have one start Maya, then those would run serially, one by one. Another thing that I would like to recommend, it might not work with, well, so if you are basically opening a lot of heavy Maya files, it might get really on a local machine, it might clog your memory and you won't get far. So prudent thing to do would be override your parameters into single on a Maya server thing, so you wouldn't run out of memory or whatnot. Yeah, so command send. How would you do stuff with the server? So basically, there is command send node. It sends command to the actual application server, in this case Maya, and it supports mel and Python. So to write mel, you need, as your first string, you need to write /mel, and then it will, take it as ML script. Python is by default, and you don't need to initialize it. So it's a great thing. You just write some stuff. And Maya.cmds and Maya.mel are already pre-imported, so you don't need to worry about that. Logs. So if it errors out, then it's you'll see an error on the work item that has failed, but sometimes things just fail, not directly. You don't need the results you're expecting, so you might want to print something out. And this is a little bit confusing. You get the print output not on the command send node work item, you get it on the begin server. So yeah, in the end you get your print output. And in Python, this is probably just my lack of knowledge of Python. I couldn't get the just print to get onto the begin server. So if you print from mel, it does the trick. So yeah, I add this little function that basically adds some log from my Python nodes from command sense, and it gets out into a work item. So reporting data back. So if you are having, for instance, you need to just export some Alembic and do stuff inside Maya, you don't need anything to know from Maya in Houdini, then you wouldn't need that. But say you do want to know in PDG, you need to know, for instance, how many nodes are there, what files is this file referencing, and whatnot. And for that, you would need to get the data, some attributes back to PDG. And this is done by report result data function. Let me show it. It actually doesn't. So in the document, in the docs, it is this function is from module PDG CMD, right? And it has some different signature, but for command send, it has only 3 parameters: data, result data tag, and hash code. So the data might be a list or a string. Yeah. Sorry for that. So let's continue. Report result data actually gives an attribute, makes a result attribute, right? So those are string attributes, float attributes, integer attributes, and for PDG specifically, those are the result attributes. So these are like files that PDG has created, right? And report result data creates only result attributes, so that's why it's only strings and lists of strings. But you might want to have those attributes converted into regular attributes, and this is done by result data by Python script, and it takes result data and yeah, sets a string. So you query result data from the upstream item, and then you set a string from that. And here, yeah, we can see that character Ellison, character Sophia main. This is the third stuff, third result attribute, and it got to my node. Yeah, so we have a my node attribute, character Sophia main. So sorry for this technical pause. So let's just have a yeah, Python scripts, right? So it's easier when Houdini works. So just cook it. It starts Python, starts mypy, and we can see that it's really mypy. And yeah, we can go here and see that indeed Maya does work, which is a rare treat sometimes. Sorry. File pattern. So file pattern, if you're new to PDG, and I am, so what it does, it just basically uses wildcard symbols and creates work items for files that it has found. So let's just to cook it, and it will. So I have these dummy files here to show the stuff, and yeah, we can do another script. So this time we need to import mel, and besides just printing that Maya works, let's see if it does. So open the file and just print whatever root nodes there are, right? So this one, Maya starts, and we go here and see show the log. Oh, so it doesn't show. Oh, it does. And here we have, yeah, the list of our nodes, right? So this is also custom, but we can use the PDG mypy variable, whatever, right? So let's get into more, let's get into actual Maya. So housekeeping tip, use a switch for your test stuff and for your actual project data. As a very powerful tool, used carelessly, it can be very dangerous. It can do a lot of damage. You can accidentally delete all your project files, create some tens of terabytes of data, clog your render farm for whatever. So yeah, it's a good practice to have one file, one work item. You test stuff, you double check, you triple check, and then only you go to an actual cook the network on an actual data. So Maya server starts. What we do here? So here we have an open file node. Well, it's command send, but it's what it does. We have the report log function, which I use for just reporting, writing some stuff if it to check if it works. Create a new file, and then here we have an in file. So this PDG input stuff is, those would be these guys. So we have an output. This is a result attribute. This is a file, right? And here we have an input, right? And this is the same file. So we can refer to this one by at PDG input. And if we select work item, it expands to proper value. These attributes are actually global to Houdini, so you can reference them in any part of Houdini, and selecting the wedging works in this way, I believe, right? So, and here in this node, let's just print some transform node name and see if it shows up. And it doesn't. Now, why it doesn't? Because it gets here to the begin server. We open this one, a lot of Maya stuff, and yeah, use a lock and we get the nodes here, right? So let's do something more interesting. Let's report those nodes as an attribute to a work item. So let's cook this one. And probably I'm not feeling adventurous enough to cook all of those, so I cancel current cook and go to, make this one just one file. Well, the open file is the same. Just open the files, opens the file, and report what it does. Look for transforms, and report those. And just write a log for good measure. Right, it does. And what we can see here is in output, we see all these Maya nodes that it has found, right? So we can use these later in the graph. So, well, we have these little attributes here, so how can we use those? We can use those, for instance, we can expand those into the separate work items. Let me show you how it works. Let's just make it to 0. So again, opens the file, reports result data, Maya transform, right? It still opens the file, it's kind of good. So now it's reported, and we can see these are the nodes here. Now we expanded those. And work item expand, it takes these output attributes and create a work item for each of them, well, by default. But in order for it to work inside this command chain loop, it needs to be set dynamic. If we set it to automatic, this actually wouldn't work. So it will start a server, it will try to open a file, and it will error out. So, because these are, I believe they are not connected, so this node needs to know how many items we're having. But I don't know the correct technical explanation for that. So if this is set to dynamic, now this understands that, let me just dirty this one and cook it again. So, it created a work item for each node, for each character or prop inside that file. Then what we can do, we can create an attribute to make it an input or output attribute, and just make it an attribute, a regular attribute that we can access anywhere in Houdini. And this is, yeah, so we have this, well, let's select another work item with a more, yeah. So we have a character as an input, this name, and now we have Maya transform, and it has this value, right? So, well, we have this as an attribute, then let's do something again. So, up to this point, these are sending stuff to Maya, and these two are doing things in process. And then we can, so we have all these nodes. Inside Houdini, we have Maya nodes. That's kind of cool. Then we can select them or make some more stuff that makes some more sense, right? So this one needs to be dynamic. That's the important point. And yeah, let's have a look how on a little bit more sensical example. So here we have some shots, right? A few shots. Yeah, just some random names. So based on each shot, so we have this file name, right? And depending on your name convention, we can get a lot of information from this shot, just from the file name. So we can get a lot of metadata. So we have a Python processor here, and what it does, it expands the file name into what project it is, what sequence, what shot, what version, and let me show you how it's a little bit more complicated. But yeah, it sort of does the upstream item. It takes the upstream item attribute, directory and file name, and split those into different variables, and then sets it onto each work item. So version, Alembic directory, and whatnot. So a few of these shots might be the same shot but different versions, and say we need only the latest version. And here, which one? Yeah, so this one, it has shot 2 version 1, and this one, well, there should be another shot with the same version, but here we have only the latest versions of each shot, and it's done by Python processor has this handy menu here, clone upstream items, but you don't necessarily need to clone all of them. You can clone them on some specific condition, which means you can sort of make this fun int or filter your work items. Then we get to fun stuff. So this is a digital asset. So here we have an open file, and this is fine. But the power of Houdini is we can use all these nodes we created as a command sense and whatnot, and we can we can make digital assets out of them. And those digital assets really allow us to work procedurally. So this is open Maya file, and what it does, it just opens Maya file. But you might want to do some options on that. So, for instance, preload some plugins before you open a file, or Maya Open actually has some options to it. What do you do with references? And if we enter here, let me show you real quickly. Open file. It's a little bit more complex, but nothing too fancy. Well, report user log as always. We create a new file in case we are using. In case it is not a fresh Maya session. Then we read plugins, right, which we want to preload. read an input file, load reference. This is probably the channel. I'm not sure this is the most effective way to do the correct way to do it with the command send, but it sort of works. So yeah. And yeah, then we open the file. But the thing I wanted to do here as well is to get the animation range, so we can use it later for export as export options. And yeah, let's just see how let's just cook this graph and see the actual attribute. So it opens the file, and this node reports result data, my mean time, my max time, and animation start time, whatever. So then in this Python script, I read it as a result data and set the fstart and fend attribute. So if we go here, yeah, we have an input, my mean time, my max time, and here we have fend and fstart. Those can be used later, and we will use them in this actual network. And this one just deletes the script attribute. So the Python script node creates this attribute, which contains the script itself. It's kind of a lot of data, a lot of stuff. So it clogs the interface or delete it. Then we go into get my references. So here we open the files, and each work item is its own file. But this one actually looks for references inside. So there is a reference technology inside Maya. And yeah, so what it does, it looks for references and reports them. So in this file, we have this many references. So it reports not only the reference file itself, but the reference node. So the same file can be referenced several times, and we need to know how many times each file has been referenced. And yeah, then this, actually I could have used the work item expand, but I needed more control, because if I use expand onto this, I have I have reference nodes and reference files in the same thing, and expand would expand each of these into a separate item, and I only want to expand based on files or based on nodes. Either of them would do. So yeah, here I do exactly that. Yeah, kind of running out of time. This one repaths file, so it's basically just a Python script that works on an attribute, right? So you just search and replace. So for instance, if you have different file paths, it will, for instance, from C to, I don't know, proj or whatever. So from Windows to Linux and whatnot. So another thing would load actual references. So let me make this clear. I'm kind of wobbling around. At this point, each item is a Maya file, right? And at this point, they become, each work item becomes a Maya reference inside a Maya file, right? And then we repass those, then we load them, right? And how to load the reference? Just with a Python script, which, yeah, reads an attribute and loads a reference. And init some initialize some attributes for Alembic export. So we need list of objects and a file name to export Alembic. And here we do that. We do exactly that. So we have a reference file. We have an object to export. This is a Maya node name. And ABC name will get, this will be the name of Alembic file. And then we get into, export Alembic. So what it does, it exports Alembic, selects a node, and goes into, into a file. And those could be different based on an individual work item, right? So if we select another work item, it will export another Alembic file. And so if you have different files with different frame ranges, I remember I told you the fstart and fend. So this will be different exports based on that exact attribute. And if we actually go to here, it shows it exports all of them, right? So to summarize, this is basically how you do it. It took me about a week to set up. So the MyRob thing, well, it took me months to get started, to get into Soho, to brush it up. There was a lot of troubles with that, but with TOPS it was kind of intuitive, kind of fast, right? And let me show the actual. So the output context I showed you earlier. This is the same thing. This is the same thing as MyRops. It does the same stuff and took me about a week to do, right? So kind of great, exciting. If you don't have a pipeline, if you don't have like those pipeline tools, I mean, big companies, they have this sorted out. But if you're a small team and you kind of doing it, don't have much time to invest into this sort of thing, PDG is a great thing. You can set up these things really fast. Well, it takes some learning, but not that much probably. So as a conclusion, this is what I got to. I'm sorry for the technical difficulties, and I appreciate you coming to hear this talk. Thank you so much. Do we have a time for questions? Sure. 3 minutes. Okay.
Actually, I have two. Stop.
Yeah.
First question: did you spend any time working with like shotgun or an equivalent, and using that alongside PDG to, query, check in, check out, something like that?
Exactly. That's amazing, amazing question. So the right side here actually. Here, I guess. This node here is a Python script that reports to ftrack. We use ftrack. It's pretty similar to shotgun, and it does that. So.
And then also, obviously, for your demo, you were doing everything locally on your machine.
Yes.
But I'm assuming on a certain level you're sending things to the farm using this.
Yes.
Are you using like a standard farm manager like Deadline or something like that?
Yeah. So things with the farm are kind of interesting. So for the ROP setup, we use Deadline, and we have a custom ROP for that, which supports all the custom nodes we have. And for this one, I didn't. It comes with a deadline, with the default deadline scheduler, and I managed to send it to the farm, but not more than that. So I suspect there would be some challenges there. And I am really looking forward to schedule a masterclass if one should come out. So but the great thing about this would be to send it to the farm, because locally like 100 shots would take forever. Yeah. Okay. No one else? Great. Thank you so much. Oh, yeah, sir.
I was wondering, you made a few HDAs to help you out with the Maya stuff.
Yes.
Do you see using a lot of HDAs as part of the overall PDG workflow, and you see side effects maybe supplying some of those out of the box?
Yeah, basically the idea would be to make everything into HDA, right? So you don't you sort of boil down your regular working patterns into a box, and then you use those all over the place, so you don't need to spend time developing this. And I'm not sure I understood the second part of the question.
Oh, well, I don't know, do you expect side effects to supply some of those Maya commands? Like some of them seem pretty generic that should maybe come out of the box, I don't know.
Should I? Yes?
There's always the OTL store.
Sure, yeah, but we have, so why didn't I post the MyRop thing? Because people do things differently, and yeah, it's kind of to debug it for people to use would be whole other challenge, but yeah, probably. Okay, not to steal more time from the next speaker. Thank you so much.